We move to our next speaker who's here in person. The topic is fairness in reviewer recommendation at Elsevier. And our presenter is Daniel Keshov. And he's already entering the stage.
Hello.
The floor is...
Brilliant. Thank you very much. Thank you, everyone, for coming. I know it's the end of the day, and it's been a long day, but thank you for holding in. I'm Daniel Kershaw. I'm a data scientist at Elsevier. This talk's going to be focusing on fairness, and particularly focusing on fairness in the reviewer recommendations we have here at Elsevier. Brilliant. So a bit of an overview first. I'm first going to introduce Elsevier for the people who don't know who we are, and then talk about editorial data science, along with the challenges in reviewer recommendations. I'll then move on to modeling finding reviewers as a multi-sided marketplace, along with focusing on the available data that we have and the system architecture that we've implemented. And then I'll move on to the main point of this presentation, bias in data, particularly bias against women and minority groups and how they are disadvantaged by academic data sets. I'll then move on to discussing the potential bias in our recommendations, the metrics we use to measure bias, where we use these metrics in production and development, and how the bias has influenced our design decisions. And finally, I'll touch on multi-objective optimization as a way of protecting user privacy and time. Okay, so Elsevier. We're a global publishing house for the people who don't know, but ultimately the mission of Elsevier and the people who work at Elsevier is to help researchers and healthcare professionals advance science and improve health outcomes for the benefit of society. And we do this through numerous ways. And one of the ways we do it is supporting a publishing ecosystem and supporting the authors in it. Elsevier, we solicit and manage submissions for 2,500 journals, which results in roughly 2.5 million submissions a year, which is managed by an army of 24,000 editors. And ultimately, we rely on 1.4 million reviewers each year to help understand and publish these papers. All of this is backed up with a production technology backbone, which allows us to disseminate each year 1.3 billion articles and archive 17 million publications on our different platforms. So where does the reviewer recommender fit in here? And what are we trying to do with the reviewer recommender? What's the main question we're trying to do? So given a submitted manuscript, the question we are ultimately trying to ask from our AI system is, does the reviewer fit the manuscript? Have they published in this domain? Are they an expertise in this subject? Are they a good fit? Would they be a good reviewer? But this isn't the only question we're trying to gauge. Does the reviewer fit the journal? Some high-impact journals will require high-impact authors. This could be due to seniority, the length of their career, but also some journals are really good journals for PhD students or people new on their research careers to enter the reviewing field and to learn how to review papers. But then we also have to ask the question the other way around. Would the reviewer want to review for this journal? Are they busy? Have they declined numerous times previously? Would they want to engage? Because there's no point asking them if they would want to review if we know categorically that they're not going to. So this ultimately means that the reviewer recommender that we're developing is a multi-sided marketplace where we're trying to find the fit between these three personas or items: the submitted manuscript, the potential reviewer, and the journal, asking questions such as, does the reviewer fit the manuscript, and does the reviewer fit the journal? So we have this in production. It is used by thousands of editors every day and processes all the manuscripts we get. And this is the tool as it looks today. And some of you may have seen this. On the left-hand side, we have the list of proposed reviewers from a given manuscript. And because it's a decision support tool, we give as much information as we can to the editors, allowing them to make that final decision. Because we're not there to replace them, we're there to enhance what they're doing. So you can see here for this made-up author that we have their publications, their tags, along with their keywords, and along with additional bits of information, such as if there's conflicts of interests or they're from the same country. But what data really drives this reviewer recommender? What do we rely on? Move slide. Ultimately, what the reviewer recommender is trying to do is speed up publication time and ultimately trying to reduce the manual search and selection effort by 80%. But what data do we rely on? Ultimately, it's high-quality data that we rely on, and at the core of our product is Scopus. Scopus is one of the world's largest bibliometric databases, consuming data from 7,000 publishers around the world. Through the internal data science teams and machine learning efforts, this distills it down into 17 million high-quality author profiles, which document people's research interests and publications. And from this, we're able to use this as our candidate set. On top of Scopus, we layer high-quality psychometric data from SciVal. This allows us access to H-index, field-weighted citation index, along with journal impact factors and site scores. So we know exactly, for it down to a quite granular level, the impact authors are having. But we also have access to historical data. Our editorial platform, called Editorial Manager, allows us access to a lot of historical actions. This gives us access to who's been invited historically to manuscripts, the subsequent decisions of accept or decline, the review decision that they came up to, and what the final decision was for a manuscript. Was it accept, revise, and we can follow the flow through there. I need to say here that Editorial Manager is used by other publishers, and we only have access to the Elsevier journals, Elsevier journals historic data, but this is a very high-quality data set which allows us very fine-grained insights into the reviewing process. So ultimately, where does this all pull together? We do go with a very simple two-stage retrieval model where we have a Scopus index, we have a candidate retrieval process that takes a query which is constructed from the submitted manuscripts, and then we have a re-ranker, a supervised re-ranker based on features from SciVal along with features from the manuscripts, which then ultimately pushes through a few hundred recommendations to the user interface. But let's talk about bias. We know bias exists in academia, and especially bias in data. This is an amazing book, which I read a while ago, and there's a very impactful chapter about bias in academic data and in the academic industry. We know that nepotism and sexism exist in the peer review process through editors only inviting people that they know and people in the field. We know that there's an academic career gap and gender gap go hand in hand, with women taking more time out than men for caring duties and being pushed into more teaching exercises. This results in less research output. This means they get less known in the field and have lower H indexes or other metrics. We also know that there's effort to counter this. Double-blind review favors an increased representation of females, but this would, on the counter, mean that some review processes disenfranchise females. And we see this with some of the citation data around first author women getting less citations. And the shocking bit of information at the bottom is that men, especially men in STEM, are less willing to accept all the evidence that there is bias against women, particularly in STEM. But what's Elsevier doing about it? Every year we publish a gender report about the current state of the gender inequality in science. I have 20 copies on the desk in the hall, if anyone wants a copy. They're very thick, I don't want to take them home with me. And they give a very stark look into science. So if we look at the field-weighted citation impact of women first authors, they are generally less than the authors across all other papers. And if we look at some cohort analysis of the gender ratio of authors who first published in 2009, every subsequent year, less and less of that cohort have published, indicating men are publishing at a higher rate. But Elsevier is committed to countering this, this bias and increasing diversity. We are actively targeting greater gender diversity in the reviewer pools, and we are trying to address the various layers where implicit bias can come into play through peer review process. But what we're doing at the reviewer recommender, it's a people recommender, and people have characteristics. And these are the characteristics we use to measure the bias in our systems. We focus on the UK Equality Act of 2010 for our definition of protected characteristics, where it defines protection in relation to discrimination. And we focus on three: age, race, and sex. However, we don't have access to this data in Scopus. They're protected characteristics. So how do we do this? We use proxies. For gender, we use inferred gender, which is Scopus name, location, and the name sort API. We understand this isn't perfect, but it gives us something which we can measure with some confidence. Age is scientific age is a proxy for age, and this is the difference in between the first and last year of the publication. And the location of origin is proxy for race. It gives a geographical location, and this is the location of the first institution where the author published. But then how do we measure? As we saw yesterday in the workshop, there are a number of different ways. For us, we focus on group-based fairness, where we treat protected characteristic groups equally. So how do we measure this? So I'm going to introduce two measures here. The first one being demographic parity. The definition of this is the proportion of the positive outcome should be proportional across each group. So we can see here that we have some numbers. So for men, we have 48 who have been recommended out of the 100 in the population, with a selection rate of 48. For women, we see 12 out of 25, again 48%, so the parity is 1. And our denominator is scopers. So elsewhere, we're focusing on the distribution of scopers. And in the US Equality Act, the 4/5 rule is enforced, which says that there should never be more than 8% difference in these numbers. For equal opportunity, though, we look at the labeled data that we have. So we're looking at the qualified proportion. For men, this is 45 out of 90, so 45 who have been recommended who are qualified out of the 90. With women, it's 3 out of 5. This means that the equal opportunity ratio is 1.2, favoring women. The labels here are from manuscripts which we've had run through our system in the past and who have been invited to review. So where do we put this monitoring? We have a number of different components we can monitor. So we break this down into 2 steps. First of all, we monitor the candidate selection. The aim is to find a candidate to review a manuscript. The method is a query, and the measure we focus on is demographic parity per discipline. So we do an analysis per discipline. This means that we are selecting at a proportionate rate for gender in each discipline from Scopus. The second one is ranking. So for this one, we want to apply supervised learning to re-rank the model. We use an XGBoost model with some user features, some manuscript features. And so the metric here we focus on is equal opportunity. We want to know the positive labels are being selected at the same rate. So these combinations mean that we can understand during development and production what is going on. And through being able to monitor all these the different biases and the different components allows the data science team at Elsevier to really experiment and understand the bias held within the data. We mainly focus on pre-processing and in-processing methods. Post-processing relies on access to the protected characteristics at prediction time, which we do not do. So in pre-processing, we have experimented with feature modification and data reweighting. And in processing, we've experimented with reduction approaches via constraint optimizations, along with adversarial debiasing approaches with differing results. But at the beginning, I said we also focus on a user's privacy and time constraints. So ultimately, it's a flow when someone's invited. Someone can decline at multiple steps. So we use this to blend into our models at the end and give the editors the understanding of how busy an author is to maybe not send a review if we think they're going to not accept or engage, because there's no point in annoying someone with an email if they don't want it. But ultimately, going through this process of looking at bias and fairness within our reviewer recommender has come up with Elsevier coming up with a number of design decisions when building recommenders. First of all, we embed metrics, bias metrics, at every decision point that we do. We set baselines internally for us to target. We monitor these in development, and we also monitor them through dashboards in production. We try treating a lot of the recommendations we do as multi-sided marketplaces, and we don't use sensitive characteristics in our recommenders, such as gender, age, or geolocation. And finally, we don't use any highly correlated metrics, such as H-index or total number of citations in any of our recommendations. Thank you for listening. I'm Daniel. If you have any questions, please ask.
Thank you, Daniel. Thank you for this talk. While the first one is entering the microphone, I will ask first the online question. Great work. For race, would it make sense to look at author names instead of country of the institution?
For author, potentially, yes, but you could, or you also, Throughout the proxy work, there's the issue of intersectionality and overlapping sort of protected characteristics. So what we say is like the three that we have are simple enough to explain to people and understand the constraints around them. Using sort of name as a race may become a bit more complex.
Okay, thank you.
Thank you for the presentation. In your earlier slides, you talked about the high impact factor journal, where you require maybe senior researchers to review the manuscripts and stuff like that. But in your final model, you removed H-index and citations, the features like that. So my question is, with this current model, how you are going to differentiate the high impact journals and in order to search for the high quality researchers or senior researchers to get recommendations for the high impact factors journals and for the average or lower average impact factor journals? How you are going to differentiate these things without using high H-index and number of citations count?
So we can also use field-weighted citation index score, which is seen to be less correlated with gender. Even though there is potentially a slight correlation, that still gets us the results that we need. H-index, we can very easily predict gender from that, depending on the field. So what I'm trying to say is there's proxies we can go down.
Okay, but my question still is there, I guess. You removed these two features from your model data, and on what features basis you predict reviewers for high quality journals?
Do you mind saying that again?
So let's take the example of high impact factor journals.
Yep.
Okay, your target is to find senior researchers or you can say qualified researchers to review those manuscripts, right?
Yep.
That's the target. So you removed H-index and number of citations in your data. So when you remove these data features, what are the data features that you actually rely on to identify the target reviewers?
So field-weighted citation index, because that is less correlated with the gender characteristic. And then with some secondary metrics, such as the number of times someone's published within a certain topic of prominence, along with their distribution of ASJC codes that they've published in as well.
I see. Thank you.
I take a question from online because it's also dear to my heart. It is by me, Faraj. How do you handle unknown or non-binary group membership? Have any thoughts about that? Because you're inferring gender, and like with the non-binary folks.
We are completely open about this. The system we have is an imperfect way of measuring the plethora of gender and gender expressions out in the world. But by treating it as a binary variable and having a threshold, it allows us to measure something that gives us an understanding of how something's working. And the reason why we say we don't then use gender in the end product is because we are aware that it is to start with, it is a flawed way of modeling gender, but it allows us to get 90% of the way there to understand what our system is doing to society.
Okay. Have you thought about how to model this group as well? Because then I would be very happy to discuss that.
We have internal discussions all the time, and it goes through numerous rounds of review on internal ethics groups. We do have one label which is sort of a non-label where if we don't have confidence, people are labeled as none. And then there is also work with the editorial platforms where people are starting to be asked to self-declare gender as well upon entering the editorial management system. And there is potential work at looking at how we can use that in our monitoring system as well. But we're still very early on in the process. Okay, thank you. As a matter of time, I move to the next talk. There are lots of questions online and on site, so we can discuss on a boat tour maybe.